Hello everyone, welcome to my channel. This is an educational channel where we discuss different, mostly theories of everything. Uh, Theories of everything that you probably have never heard of, cosmologies, systems of theory, and all-encompassing theories that attempt to describe some type of unified reality. And today is video number 178 on the reciprocal system of theory. And this theory was first proffered by Dewey B. Larson in the 20th century. He died back in 1990, but not before. He wrote many books and a lot of articles on the reciprocal system. The basic idea on the reciprocal system is that we live in a universe of motion, not a universe of matter, not a universe of energy, but a universe of motion. And other people have come up with that before, that idea. Thomas Hobbes, Arthur Eddington, Rene Descartes, and others have posited the idea of a universe of motion. But Larson distinguished himself by defining motion or redefining motion as the relationship between space and time. Now, if we just use our common sense and go into what we do know about motion, that at least holds true in the first instance. What we do know is there's speed. Speed is a kind of motion. It's a way to measure motion. And speed is, in fact, a relationship between space and time. The car is moving 30 miles per hour. 30 miles of space in 1 hour of time. Space over time. Speed is space over time. And so that is true for what we know. Now, what Larson is also saying is that every scientific kind of phenomena that we know of is also a relationship between space and time. But you can't tell because it's a little bit more complicated than that, because time and space both have their coordinate aspects. We know space is multidimensional, 3 or more dimensions. We use XYZ coordinates, Euclidean coordinates, to graph out space or time or space. But we also time also has its coordinate aspects. So time is also 3 or more dimensions. So when you are looking at your basic quantities, well, speed is time over space, but there are other permutations of relationships between space or time, because time can come in 1, 2, 3, or more dimensions. And so, for example, Larson eventually derived the idea that matter is time to the third power over space to the third power. Other quantities are similar. Electrical capacitance was discovered by Bruce Perret, Dr. Bruce Perret, one of his followers. I wouldn't say followers, but one of the people who worked on the reciprocal system, as space to the third power over time. Acceleration we know to be space over time to the second power. I dropped the ball at 9.8 meters per second squared. That is acceleration. The converse of that, or conjugate of that, is force. Force is time over space to the second power. And we've got energy. Energy is simply time over space. Magnetic flux is time to the second power over space to the second power, and so on and on and on. So every scientific quantity that we know of is a relationship between space and time. Space and time both have their coordinate aspects. They can be in 1, 2, or 3 dimensions. They also have their clock aspects, and this brings in the concept of scalar motion. A scalar motion is like speed. It's a motion that has a magnitude but has no particular direction. That's really the difference between speed and velocity. Speed is a scalar motion because it's the car is moving 30 miles per hour. To convert speed to velocity, you have to add the direction. Now, the velocity would be the car is moving 30 miles per hour due east, or something like that. That would turn the speed into velocity. But a scalar motion really can be envisioned using a balloon and a magic marker. Put some dots on the balloon with a magic marker, and you blow up the balloon, and you eventually recognize that all of the dots are moving away from each other. But they're not moving in any particular direction. It's really all directions. That's a scalar motion. And if you suck in the balloon, then they are moving inward toward each other. That is also a scalar motion, what you would call an inward scalar motion. So the only direction that scalar motion has is in or out. Now, also, space and time both have their discrete aspects, meaning that they only come in chunks. There's a minimum unit of time and a minimum unit of space. They're not continuous. And when you have exactly 1 unit of space in 1 unit of time, you have the speed of light. So the speed of light is 1 in Larson's system. So that basically means Larson's system is more like reciprocal, meaning that it's multiplicative. When you have the reciprocal of 2/3, that is 3 halves. When you take the 2 reciprocals and you multiply them together, you get 1. So 1 is really the origin of the other 2. The other 2 come out of that 1. And so this 1 that is the speed of light is really the origin of this universe of motion. And then there's half of the universe that is above that and half of the universe that is below that. Einstein observed that second half because Einstein said that the speed of light is the maximum speed of the universe. That is true of the lower half, the half that is slower than the speed of light. Larson calls that the material sector. But then there is the cosmic sector where the speed of light is actually the minimum speed of the universe. Larson calls that the cosmic sector. Einstein knew nothing about that. And legacy science knows nothing about it either, even to this date. And but the speed of light is the midpoint of that. So that's kind of how things get constructed. Now, we're looking at his 1979 book called Nothing But Motion. And this is primarily a book on physics, atomic physics. And we are looking at his chapter 10 called Atoms. And he's kind of was going over the periodic table. Basically, you get atoms out of a combination of different kinds of motion. There are really 4 kinds of motion. There is your translational motion. There is your vibrational motion. There is your rotational motion. And then there is your rotational vibration. And these can come in 1, 2, or 3 dimensions. And you combine them to get all the atoms. So the atoms are really, first, for an atom, you need to have photons. The photon for Larson is a combination of a translational motion in one direction and a vibrational motion in a perpendicular direction. When you combine the two, you get a sine wave. Now, other people have followed Larson and disagreed with that analysis, and they say that KVK Nehru in particular and Bruce Perret have said that a sine wave is actually the product of a birotating motion. 2 counter rotations, when they are combined, that also creates a sine wave, which is the epsilon function of Leonard Euler. And so I'm inclined to believe the birotating photon, but for now, we're going to go with this photon that Larson has come up with. Now, when you have these photons, then when you start rotating them, you rotate this uh, in a perpendicular direction, and then you get a disk, and you rotate the disk, and then you have a sphere. So there are two two magnetic rotations, which are two-dimensional rotations that comprise the atom, and then there is an optional electric rotation, which is basically a spinning of that entire sphere that also creates the kind of the gaps in the periodic table. And Larson has a chart here, a table that he lists all of the elements and their three number components. We went over this a little bit. So, for example, oxygen is element number 8 on the periodic table, but in Larson's nomenclature, it is two-dimensional primary magnetic rotations, two secondary magnetic rotations, and two negative electric rotations. And he builds up the whole periodic table in this manner. If you'd like to see that, you have to download this book, and you'd be able to look at his whole chart here in chapter 10. We're just going to go over the text here and maybe indicate a few different things about the table. The final two groups of elements in table 3 contain 2 times 4 squared, or 32 members each. The heaviest elements of the last group have not yet been observed, as they are highly radioactive and consequently unstable in the terrestrial environment. In fact, uranium, element number 92, is the heaviest that exists naturally on Earth in any substantial quantities. As we will see later, however, there are other conditions under which the elements all the way up to 117 are stable. This has to do with what Larson calls the ionization level, and he'll get into that a little bit later. Okay, for convenience, in the subsequent discussion, these groups of elements will be identified by the magnetic N value, with the first and second groups in each pair being designated, A and B respectively. Thus, the sodium group, which is the second of the 8 element groups, N equals 2, will be called group 2B. At this point, it will be appropriate to refer back to the statement that was made in chapter 9. The mathematical development will begin with nothing more than the series of cardinal numbers and the geometry of 3 dimensions. By subjecting these to simple mathematical processes, the applicability of which to the physical universe of motion is specified in the fundamental postulates, the combinations of rotational motions that can exist in the theoretical universe will be ascertained. And it will be shown that these rotational combinations that theoretically can exist can be individually identified with the atoms of the chemical elements and subatomic particles that are observed to exist in the physical universe. A unique group of numbers representing the different rotational components will be derived for each of these combinations. A review of the manner in which the figures presented in tables 1 to 3 were derived will show that this commitment, so far as it applies to the elements, has been carried out in full. This is a very significant accomplishment. Both the existence of a series of theoretical elements identical with the observed series of chemical elements, and the numerical values which theoretically characterize each individual element have been derived from the general properties of mathematics and geometry, without making any supplementary assumptions or introducing any numerical values specifically applicable to matter. The possibility that the agreement between the series of elements thus derived and the known chemical elements could be accidental is negligible, and this derivation is, in itself, conclusive proof that the atoms of matter are combinations of motions as asserted by the reciprocal system of theory. But this is only the beginning of a vast process of mathematical development. The numerical values at which we have arrived, the atomic numbers, and the three displacement values for each element now provide us with the basis from which we can derive the quantitative relations in the areas we will examine. That's very important. So the fact that Larson can derive the entire periodic table from theory, strictly from theory, is, for according to him, is conclusive proof that that's how it is derived, comes out of theory. And now when Larson says that we're looking of the vast process of mathematical development, and that this is all properties of mathematics and geometry. Unlike legacy science, when they say stuff like that, when they're talking about mathematics and geometry, they're talking about differential equations and third level differential equations and all this complicated math. Larson is pretty much talking about counting, simple addition and multiplication and subtraction, and occasionally maybe getting into a little algebra and possibly a tiny bit of calculus. But he's talking about simple math that most people can follow when he's talking about math and geometry as well. Euclidean geometry, pretty much, it's difficult. It's difficult to follow Larson with his visualizations that you do to kind of imagine how these things are happen, but it is doable and it's not very difficult. Whereas when the scientists, go to the math and geometry, they're really kind of just doing it to exclude you. Oh, this will leave everybody in the dust because nobody knows this kind of math, and so you can't check our work, and so we can make stuff up. Okay, we'll continue here with Larson. The behavior characteristics or properties of the elements are functions of their respective displacements. Some are related to the total net effective displacement, equal to the atomic number in the combinations thus far discussed. Some are related to the electric displacement, others to the magnetic displacement, while still others follow a more complex pattern. For instance, valence, or chemical combining power, is determined by either the electric displacement or one of the magnetic displacements, while the interatomic distance is affected by both the electric and magnetic displacement, but in different ways. The manner in which the magnitudes of these properties for specific elements and compounds can be calculated from the displacement values has been determined for many properties and for many classes of substances. These subjects will be considered individually in the chapters that follow. And in addition, this is the first volume of a 3-volume set here called The Structure of the Physical Universe, Edition 2. And the second volume of this set is actually called Basic Properties of Matter. And he goes over all of the major basic properties of matter, and he derives their properties by theory, strictly from theory. And so his first chapter is called Compressibility in that book. And so actually, yeah, I believe that's the first chapter. He goes over every element and he derives what their compressibility. And in another chapter, he goes over, say, the melting point of each one of these atoms, and he derives strictly from theory what the melting point is of these various elements. And he's 95% within the experimental error value of the actual melting point of these various elements and compounds. And then he has another chapter where he, goes over the specific heat, or, you know, like he said, the valence, other properties of matter, the interatomic distance. He derives all of these various empirical qualities of atoms and compounds strictly from theory, and they agree with the actual values. So that is, that is an accomplishment that has not been made by anybody. Okay, we're going to go one more paragraph here. One of the most significant advances toward an understanding of the relations between the structures of the different chemical elements and their properties was the development of the periodic table by Mendeleev in 1869. In this diagram, the elements are arranged horizontally in periods and vertically in groups. The order within the period being that of the atomic number, approximately defined in the original work by the atomic weights. When the elements are correctly assigned in the periods, those in the vertical groups are quite similar in their properties. On comparing the periodic table with the rotational characteristics of the elements as tabulated in this chapter, it is evident that the horizontal periods reflect the magnetic rotational displacement, while the vertical groups represent the electric rotational displacement. In revising the table to take advantage of the additional information derived from the reciprocal system of theory, we may therefore replace the usual group and period numbering by the more meaningful displacement values. Okay, we're going to leave it there. Take over tomorrow. Appreciate you tuning in. Have a great day.